All right, so welcome to the NACIS morning after, I suppose. It's quiet and peaceful in here this morning. So welcome to the remote sensing session. We have 5 great speakers today, well 6 I guess, 5 presentations. And my name is Adam, I'll be moderating. So I want to start with the land acknowledgement. The NACIS annual meeting in Louisville, Kentucky is taking place on the traditional homelands of many indigenous peoples, including the Shawnee, the Cherokee, Osage Nation, and others with historical ties to this region. Indigenous people have lived on the land now called Kentucky for at least 12,000 years. Many nations and cultures have called and continue to call this place home with overlapping histories and territories, including the Cherokee, Shawnee, Osage, Chickasaw, Miami, and Seneca Iroquois people. The region is also part of the ancestral legacy of early indigenous cultural traditions, such as the Adena and Hopewell. And this mic is hot, I feel like. It feels loud. Wonderful. So we will begin today. I will like to introduce Boyd Shearer. Boyd specializes in topography and web mapping. He is the Assistant Director of the Kentucky Division of Geographic Information Systems, or Geographic Information, which manages the KyFromAbove initiative. Great, thanks, Boyd.
Thank you, Adam, and thank you, NACIS, and you all for allowing me to present. Yeah, it's pretty hot. And so DGI, we do GIS, and so it's, can go without saying, but okay, thank you. So today I'm going to present about visualizing lidar point clouds, and we often have visualized point clouds by colorizing it with RGB imagery, aerial imagery. I'm going to propose something different. I have a lot of links in this presentation, so if you go to this URL, it will redirect you to this presentation. So a little bit, excuse me, a little bit about myself. So I started this project a couple years ago looking at lidar point clouds as I was teaching at UK. And just recently, yes, I did move into a position where I'm working statewide, so I love teaching. It was helping student by student. Now I see myself expanding it out to helping the Commonwealth. And so this Kentucky from Above initiative originates and facilitated by this DGI organization. But my underlying DNA, and I presented here since 2006, not consistently, but I map under the name or group called ArcGIS mapping. And we have some maps in the raffle. I don't know if it's happened yet, but some hiking maps if you guys need to get out and get lost while you're here in Kentucky. So what is Kentucky from Above? Well, so it originally was called Kentucky Aerial Photography and Elevation Data Program. Kentucky from Above sounds much better, right? It's much easier to consume and to visualize. We're looking from above. It's been going on for a while, and it's ongoing. And what's interesting about this project, it's not a single source origin of funding, right? And this is critical, but if you look at the funding partners, it shows the collaborative nature that we are looking at. So we have local organizations, counties, we have cities, we have these public-private entities, of course we have federal organizations and then state organizations. So all of these come together to produce this data, and here's the important part. The common goal is it's statewide, it's comprehensive, and it's open, it's accessible, and that's what really drove me it gave me a passion for this data, because not only can the state use it for their kind of business processes, but individuals, citizenry can consume this data and make what they will, and that's what I did with this data. So we look at the data, and what's important to understand, it is statewide, but we have different types of data. So we have digital elevation models, which are derived from point clouds. And all of these are available, and with these links, you can go to an interface that will allow you to access the data. The important part is we have multiple phases, meaning that we have vintages that go between 3 editions. There are 3 phases, and if you look at the time frame, so any place in Kentucky, you parachute into any place in Kentucky, you're gonna have elevation and point cloud data roughly 5 to 10 years apart, right? Same place, but different vintages of the same location. That's elevation data. Then we have aerial photography, and it's also statewide, and we have 3 phases. So we have 3 discrete points in time that we can compare and look at. And you think about the resolution. Now, this is pretty amazing. It's the highest resolution, open data, comprehensive, accessible across the state. We're talking 2-foot pixel DIMMs across the state. And we have 3-inch aerial photography, 3-inch per pixel across the entire state. And so that gives us neighborhood context, right? So we're not looking at, we can zoom in and understand how a neighborhood at that scale is configured. So let's just look at the state. This is the 3-inch aerial photography shot in the past couple years. And I zoom, has anyone been to or know of Jefferson Memorial Forest? Okay, cool, we have some local folks. That is it's a county park. And if you need to get some outdoor recreation, that would be the closest spot. So I'm just randomly zoom in, and we can see this 3-inch is highly detailed. You can access this tile multiple different ways. You can load it into QGIS, ArcGIS, whatnot. If you look at the elevation data, the phase 2, we start to see features in the landscape that I like to think allow us to do field work without being in the field. You can start to see road cuts that maybe wouldn't be apparent in the aerial photography, but you can certainly see it in the elevation data. So those 2 things together give us awareness of the landscape that maybe we wouldn't otherwise have without visiting there. And that's the point of mapping, after all, of topographic mapping especially. So now we look at the point cloud data. So that elevation data is derived from the point cloud. And I'm sure we've seen variations of this type of data where we have a point, we zoom into, and we start thinking about, digital twin. We've got this, model of a city. Here's Lexington. This is Patterson Office Tower, the University of Kentucky. And, when you first see that as a mapping student, you're just like mind blown, right? You can do this, I can do this, I can take this data, I can colorize it and give a realistic model of my hometown. And that's what I did with students. I said, just zoom into your hometown, download these tiles for your town, colorize it, and you're like, this intimately. What's important for that is that they know the data is also good. Because if you map where you can verify the quality of your data. So we have this, and I'm thinking, well, this is great, but since we have these different phases of data, why not look at change? And how can we visualize this change on a map? And so we have the point cloud. It has above ground features. We have 2 different vintages, and the math is quite simple, right? It's conceptually pretty easy to grasp. You have point cloud most recent, and then you have the older point cloud, and you just subtract the difference between the surfaces to see change. But how to visualize is a bit trickier because it's not as simple as taking 2 point clouds and subtracting each point from the different vintages to get it. So we have to colorize. Instead of using that RGB that I showed in the previous slide, let's see if we can find change in these digital surface models, right, where if you subtract the most recent from the later point cloud, you're going to get, if you have increased height, it's going to be a positive value. If you have a negative, decrease in height, you have decrease or increase and decrease in that area. So when you look at it in, I have a notebook, ArcPy Notebook that will show how to do this. But the hook here, I think, is recognizing that when you colorize a point cloud, you need an RGB image. You just can't take data in ArcGIS that I'm aware of and then colorize a point cloud. So what you have to do, and I'll point this out, is that when you have a raster that you want to use for colorization of a point cloud, you need to convert it to an RGB. Because most of these rasters you're going to get won't be RGB, they'll be data rasters. So when you force it to RGB and render it, you can then use it for colorization. Now, to get at this, to visualize it, another thing we can do is take the 2 point clouds. Once we colorize them, I'll show it in a second, we can show them in the same view. Because where you have a decrease in height, or an increase, you can see the two together in the same view. So this is an example of that raster here, or point cloud, and this is the colorization. And so we look at decrease in height as being a red, a darker red, and an increase being a darker, progressively darker blue. And so this is University campus, UK's campus, and we've had a lot of change on campus, and that's was kind of the inspiration behind looking at this method. This is, as you might recognize, an athletic complex. We have football stadium, baseball, and that we have witnessed quite a bit of change over the years. And so this is the Poetry viewer, and once you know, it's a pretty common open source point cloud viewer. When you have these two point clouds together in a scene, Poetry will separate them into two different point cloud objects that you can turn on and off. So this shows us a decrease in the case of this football or baseball stadium. We see there wasn't a baseball stadium in 2010. To make it so, a few trees were removed, right? We had some grading of the area, decrease in height. So this decreased more than this area here, and quite a few trees were removed here for the expansion of the football complex here. And when you look at the increase in height, notice that when you superimpose the two point clouds, you can clearly see what was lost and what was gained. What impressed me, if you zoom out especially, is the amount of growth of trees exhibited over 9 years. And so imagine if you're a neighborhood, you're a small community, and you're looking at projects that have changed your community. How can you visualize and even quantify those change? With these two point clouds visualized in this way, I think you would provide a kind of a compelling argument. And looking at the growth of these trees here, quite substantial. And so urban forestry initiatives and urban forest canopy cover would be, I think, important, or this might help with those objectives. Okay, so let's take a look at the notebook. I'll just bring this up. And the first thing we have to start with, and you can download this and it should run, but you need to have a point cloud, right? It should work with any point cloud you build. And so once you add this point cloud, so you load your LAS into ArcGIS Pro, and you need to filter. Let me see if I can open this. So if you have a point cloud in ArcGIS Pro, you can right-click, and you need to filter your points. In Kentucky, we have all above-ground features, as well as some error, some noise points that are classified. We need to simply interactively remove those, filter them to the surface we want. And then when we create the actual raster, so we take this point cloud, we rasterize it, we use this tool LAS dataset to raster, and when you interpolate, you'll need to pay attention to the cell assignment, the cell size, so you'll have to determine that from the density of your point clouds. You probably have guidance from where you pull that point cloud as to what that value should be, the sampling value. But the cell assignment you want to do for maximum. So if you get a bunch of points in a cell, you just say whatever the highest point that's valid that you know occurs in that cell, you take that elevation value and assign it to that cell. So once you have those two, or that raster produced, it's actually quite simple. You find those rasters, and here they're in a geodatabase, and we say, okay, we've got these two DSMs, they're in two different phases. Let's load them as raster objects. And so we use the spatial analyst, arcpy.sa.raster. So that loads it as a raster in our notebook. And we can just invoke that variable name to see the raster. We do it for the second layer. And we then do again, that's simple math, right? We take the more recent raster, we subtract the older raster, and we get what I call a change uncleaned, because we have different scan angles for the point cloud when it gets converted to a raster. Edges along tall buildings might provide artifacts in our elevation. So we can use a focal statistics tool here, which says, go cell by cell and give me the neighborhood, a 3x3 kind of neighborhood, and give me the median elevation value, because if there's an outlier, we'll just kick it, because most of the points or elevations might group around a few values. And then we can find the increase and decrease with this conditional statement, which says if your change is greater than 2 feet, because let's say you have 2 feet above or below this surface that changes, if it's greater than 2, we're going to take the value of this change, otherwise it's 0. And so fiddling with these values, tinkering with them, what I think, I think would help kind of dial in the type of visualization you're going for. So once you get these rasters created and you visualize and say, yeah, I like it, then you do that step where you right-click, export, save as a RGB, and then you can proceed to colorize your raster, or I'm sorry, colorize your point cloud, and then visualize that raster in your project. Okay, I think that's it. It's pretty short, sweet. We got 5 presentations, but I encourage you to go to this presentation and check out the KyFromAbove resources, as well as some web apps using open source technology to visualize these products from KyFromAbove. Thank you.